What up, geometry? Welcome to Unit 3, three-dimensional figures. Last unit was about two-dimensional shapes, finding the area of each of these shapes. Now we are going to expand on that a little bit. We're going to talk about 3D shapes. So we have things like a prism, a 3D shape like that. We're going to be talking about things of how much material it would make to make that type of box. How much can that box hold? That would be volume. Surface area is the area of each of the faces. And we'll get into all that stuff, right? So first things first, before we get to the volume and surface area of 3D objects, we have to know exactly what the heck we're talking about, how to name them, all that kind of good stuff, right? So on my end, I have all this filled in, but I'll go through and talk about each one of them so you can follow along, fill in what you need to fill in. The face of the 3D objects are just going to be the flat pieces, right? So the front, the back, the top, the bottom, the sides. Cylinders are going to be a little different because they have rounded, right? A cylinder is a can of soup, something like that, where the faces would be the top and the bottom. It doesn't have any of these rounded things, or it has rounded things. So the surfaces of a three-dimensional figure are solid. They have to be flat, all right? The edge is the line formed by the intersection of the two faces, okay? So edges going along the outsides, okay? Those are all edges. Those are line segments. So you might have to name line segments when we have to name what are all the edges, all right? The vertex are all just the spots, the corners, right? Those are all the vertex. Now, the important stuff, the base. We need to find out what the bases are. There's two of them. If it's a prism, there's two bases. If it is a pyramid, there is one base. We need to find out what these two bases are in order for us to name these shapes, okay? So that's going to be our focus. A lot of our focus today is what's the base, what are the shapes that it's made up of, is it a prism? A prism and a cylinder, when we go through and do the surface area and volume, they're going to have similar formulas, similar concepts, because they have two bases. Now the difference between a prism and a cylinder is a prism looks like this. It's got nice edges and corners. Think of a box of cereal. Versus a cylinder, it has two congruent bases, but those bases are circles, so think of a can of soup. It's rounded all the way around. So those are a little bit different. Okay? Then we get to a pyramid and a cone. They each have one base. Okay? A pyramid, they fold up to create a point. They have triangular side faces, right? Versus the base, it's one on the bottom. And all the triangles fold up and they create a point. A cone is the same concept, right? Think of a sugar ice cream cone. It's got the point at the bottom. The only difference is the base is a cone or is a circle, right? And a cube, you guys know or heard of, playing any board game that has pair of dice or Yahtzee's got 5 of them. They're just squares. All right, so what we are going to focus in on is trying to classify what we call polyhedrons. A polyhedron is just a many-faced shape, right? 3D shape. That's all it is, right? Poly is many, and we're talking 3D. So in order for us to do this, we have to follow kind of these guidelines that we got here. Look at the sides. Are they parallelograms or triangles? If you see a lot of rectangles and stuff like that, it's a prism, usually a prism. If it's triangles, if you see a bunch of triangles, it is a pyramid, right? If you see circles, then it's either going to be a cone or a cylinder. It depends on how many circles there are, okay? Look at the bases. If there's either one or two, what shapes do you see? The shape is how we name it. Okay, we'll talk about prisms. We might have a triangular prism, a rectangular prism, a pentagonal prism, right? And the pentagon, the triangular part of that name is based off of the base, right? So let's take this shape here. All right. If you take a look at all the faces, right, the sides, they're like squares or rectangles. Okay. We got the front and the back, those are rectangles. In the front here, those are rectangles. So we're seeing a bunch of rectangles. It is a prism. Now, all the faces are rectangles, so we can call the way it's set up now, we could just call this the base. All right, there's two bases. They are going to be parallel or opposite sides, so it's either top, bottom, side, side, front, back, whatever. And the shape of that base is how we're going to put this together as a full name. Since those are rectangles, we would call this a rectangular prism. All right, prism, because the faces are all rectangles, or the majority of them are rectangles. There's a bunch of rectangles, so that's a prism. Find the bases, we call it rectangular prism. All right, we go on to this one. I am seeing a bunch of triangles. All right, there's 3 there in the front, and then there's some dotted in the back. So that refers to a pyramid, or a cone, I guess. And you see how they all form together at this point, right? That's kind of how you can see that it's a pyramid versus a prism. All right, now we have to find out the base. Well, the base, there's only one of them. 1, 2, 3, 4, 5, 6. A 6-sided figure is called a hexagon. So we call that a hexagonal pyramid. The base goes first. The 3D shape, or the prism, pyramid, cylinder, cone, comes second. Hexagonal pyramid. All right, you guys try these examples 3 and 4 on your own. Go ahead, pause the video, try to do what you need in your notes. Figure that out. All right. Well, I'm seeing a bunch of triangles. See one here, see one here, see one on the bottom there. So this is a pyramid. And again, they come together at a point. So it's kind of sticks out. So pyramid. Now we got to find out the shape of the base. We can, since the point's here, the base can be down at the bottom. That is a triangle, so we would call this a triangular pyramid. All right, go to example 4 here. This one's tricky because I see both. I see a couple triangles on the top and the bottom, and then I also see some rectangles. So what the heck? Is this a pyramid? Is this a prism? What's going on? Because it could be both. We're taking a look, since there's rectangles, more than one rectangle, it is a prism. And then we're going to find the triangles. We're going to call those our bases. So this would be a triangular prism. This one is difficult at times where we see the rectangles, or we see the triangles, and we think it's a pyramid. Every time we see a triangle, it's a pyramid. No, it could be a mix of rectangles and triangles. You have to look, do they have a point, right? Pyramids, and even a cone, will have where the faces will meet at a specific point or a vertex, right? We don't have that over here. We have nice edges all the way around. There is no points. Okay? They all don't meet up at one specific spot. All right? So this one's saying classify the name, the bases, the edge, and the vertices. Okay? Let's just work backwards. Since they come to a point, that is a pyramid. And it looks like we have, you can call it a square pyramid or a rectangular pyramid. It's hard to tell without things. So we would call this rectangular pyramid. That's its name. Okay? The vertices, those are points. So how many points do we have? We have A, B, C, D, and E. So we call them individual A, B, C, D, and E. Those are separate points. Its edges, we have B to E, right? And these are line segments. So think back to Unit 1. We have BE, we have ED, we have AB, we have AD, we have DC, and we have BC. And we have, I was forgetting, C to E, and we have A to E as well in the back. Kind of hard to see with this picture. We have all those edges, right? We're naming them all. We're not just saying, hey, there's 7 edges or 8 edges or 10 edges. We're naming them all, right? And the base is a rectangle. You can call it parallelogram, draw a rectangle, and then it just has to go in order of the corners, so you could start at any of the corners or the vertices and then just put it in order. So C, B, A, D would be 1, A, B, C, D, whatever. Okay, now we jump down to this one. Name, it's got circles and it looks like a can, so this is called a cylinder, not a circular prism, a cylinder. Its vertices, it doesn't have any spots or edges. Okay, it's rounded all the way around, so there are none. There are none. And the bases are circles. And since we can name a circle by its center, we would call it circle P or circle Q. Right, those are the bases. That's how we would name the circles. Just use that point. So vertices, there are no vertices. There's no nice edges that come together at any corners. It's nice and rounded, so that we don't have any vertices or edges with the cylinder. It's just the bases we can name. Okay? We get down to a cone. The name is a cone. It's got a circular base, and it comes together at a point, so we would call this a cone. Okay? Vertices. We got that nice point, so we can call that point N. Right? There are no edges, right? There's no edges. Like up here, it's going from vertice to vertice. Those are not edges, so there are none. And the base is circle MN. No, sorry, not circle, I meant just circle M. And then we get down to this one. This is tricky because we get focused on the triangles that would be on the top and the bottom. And we think pyramid right away, but there are no just spots where they go up and connect all at one point. So this is not a pyramid, this is a triangular prism. Okay, its vertices are, and we got one hiding it. No, we got them all there. T, U, V, W, X, and Y. Edges, got to name all the edges. So TV, VU, TU. And you guys can write all these out. I am not going to write them out right now. You can. WX, XY, YW, and then TW, UX, VY. Don't tell me the number. I want you to tell me the name. Okay? And then the bases. We have our all of our rectangles, which making it a prism, right? All these are the rectangles making it a prism. So then we have to go with the two that are different shapes. The triangles are not, hence the name triangular prism. Those are our bases. So our names would be triangle TUV and then triangle WXY. All right. Another way to tell the type of shape, and this is how we are actually going to teach surface area, is by breaking it down into all of its two-dimensional shapes. And go back to what it looked like for Unit 9. We can go through then and find out the area of all these triangles and add up all those areas together, right? So we'd find the area of 4 triangles, add them all together. With a cylinder, right, it's a combination of 2 circles, here and here, and then the rectangular, I mean, if you think like a soup can label, if you took off the label, or those of you like picking at your Gatorade bottles, Powerade bottles, and like ripping off, it's a rectangular piece that goes around. But since the outside's circular, it looks like it's a circle, okay? We call these nets when we break them down into two-dimensional objects. So let's fill in the blanks here. A net is a diagram of the surfaces of a three-dimensional figure. And then what we do is we think we can fold and unfold them. So we can be folded to form the 3D figure. To identify the 3D figure from a net, so it's two-dimensional, try to think of folding it back up. What would that look like? Look at the number of faces and the shape of each face. Again, we're going to go back to that second slide, way, way, way back here. Our third slide, actually. Okay? Look at the bases. Look at the sides. Do you see rectangles and parallelograms or a bunch of triangles? That's going to help us determine if it's a prism or a pyramid, if it's hard to see the two-dimensional shape getting folded back up into that third-dimensional shape. So we're still looking at these shapes, but now they're like kind of folded down. So when I'm trying to figure out what the figure is with this one, I see a bunch of triangles. Okay, those are a bunch of triangles. That's going to mean it's a pyramid. All right, well, since they're all triangles, we would call that the base probably, so this would be a triangular pyramid. All right, then we talked at this one already. Take a look at the shapes we see. We see a rectangle here. There are no triangles, so it's either a prism, but then we have the two circular bases, so this again is a cylinder. So the nets, sometimes it's hard to see, but again, look for those specific triangles or rectangles that hopefully stick out. Okay? Then we get to a concept that's easy. In theory, it's easy. Sometimes it's hard to wrap our heads and brains around it. Okay? So we're talking cross sections now. Cross sections are of basically cutting a 3D shape. And then when you open it up, you take a look and see what kind of shape that you're staring at. Okay? So it's when we have an intersection of a 3D figure and a plane. I like to think of the plane as the knife that's cutting something in half, okay? Describing a cross section means to tell the shape of the slice, that it's created by, all right? So right here we have this rectangular, not rectangular, but this is a hexagonal prism, okay? We would call this a hexagonal prism. And we are going to cut it straight up and down. And so our cross section is really what is the shape of that piece where that plane and that shape, that three-dimensional shape intersect. Well, the cross section is just a hexagon. Okay? If you took that same prism and cut it the long way instead of the short way, okay, what shape would that be? Well, that's a rectangle, right? So you have to know which way it's cutting, and really if it's already there, they're talking about that red outline shape, okay? So we get to a cone, all right? The cone is being sliced right at the tip all the way down, okay? Well, what is that shape that it's making? That is a triangle. The cross section would be a triangle. Okay? Well, what happens if I cut that cone horizontally? If I cut it this way? What shape would I be staring at? I would be staring at a circle, because that's what the base is going to be. All right? So if you cut it that way, it's going to be circular. So it'd be a circle. All right, so that's in a nutshell how we're going to go through and name things. So we had the most important thing is how to name the shape, because when we get to surface area like this hexagonal prism, what we're going to do when it gets to surface area is we are going to talk about finding the area of all of the faces. So that would be a hexagon. Well, that's a regular hexagon, so it'd be 1/2 apothem times perimeter. And then we have 2 of those bases in the front and the back. And then we have all these rectangles that are just base times height. So being able to name it, hey, here's my base, breaking it down into all the shapes, when we get to surface area, we're just going to take and add all of those together. So take your time when you're going through and naming things, but it's either going to be a pyramid, a cylinder, a prism, or a cone, right? That's part of it. And then you have to name the other piece, like that triangular, rectangular, hexagonal, pentagonal, heptagonal, octagonal, right? That's how we would name those shapes. So good luck with this. Please reach out to us if you have any questions. Have a great day.